Hello everyone, my name is John from Vulgar Kitten Studios, and welcome back to our third-person camera and character controller system in Unity 3D using mecanim. And this is going to be the last installment in this initial series, and if you've enjoyed it, if you like what you've seen here, then go ahead and feel free to comment, rate, subscribe, whatever it is you do. Depending on the feedback, we may continue to move forward with this and make it a little bit more modular, and possibly even implement rigid bodies and a little bit more realistic physics. But for now, let's just go ahead and top this off. We will open up our player motor script in MonoDevelop and go ahead and add in our using statement for our helper class. And again, just like always, I'm going to go ahead and add in a summary up here. So pause the video and copy this or read it if you want to. And we'll just go ahead and start out with our public properties. So we'll need speeds for our walk, run, and sprint, and I'll just set those to some values that I found appropriate. They're really not going to be used that much, but walk I set to 3, run I set to 5, sprint I set to 7. We'll also need a jump height, so how high we can jump, and I've set this to 10. And we'll need a gravity variable to simulate gravity because we're using a character controller and not a rigid body, so I've set that to 20. And these are just the values that I found that I've liked. You can switch these around however you want. And we'll go ahead and start out. Actually, this one I want that to be public too. Sorry about editing this on the fly. But right underneath sprint speed, I'm actually going to add in our rotation speed. I've defaulted that to 100, and I'm going to change that to a public. Change that to a 140, so I want it to rotate at 140. Okay, and so we'll need 2 private variables to store our input for horizontal and vertical. And we don't need to initialize to anything. We could just initialize these to be 0 if we wanted to. It really doesn't matter. But we'll need one for our move speed. This is going to be what we actually set based on the current move state. So if it's in the walk state, then move speed will equal walk speed. Okay, and we'll also need an air velocity variable, so we'll add that in here. We'll need to cache our transform, so a transform type, call it my transform. We'll need we'll need a vector 3 to give our to transform our character controller's direction. So I'm just making a vector 3, call it move direction, and initializing it to be 0. We'll need a reference to our controller or our character controller, and so again, just like in the player character script, making a character controller and calling it controller. Same way with the animator, so we'll need a private animator. We'll need a speed state, so the state that we actually set up in our helper script, we'll need to make a reference to that, and I've defaulted mine to run. And we'll need a reference for our player character script, so private player character and call it PC. We'll need one for our camera script, so private player camera and call it camera. And we'll need one for our camera state, so we'll say private camera state is equal to camera state. So I'm actually going to change that around, and we don't want to default this one because we actually only want to set this one to be whatever our camera state is in our player camera script. Okay, so we'll need we don't actually need this, but I always put it in if I'm working with a character controller, an accessor for our move speed and whatever other values that you want to be able to access outside of the script. So like if you wanted to give like a I don't know, a temporary boost of speed with a pickup or something, or with with a buff pickup, then you could access that with this externally from the script and just set that value. Okay, and onto our start function. So again, this is the same old stuff that we've been doing before, so we want to add in network functionality, and that was my auto hotkeys firing. I apologize if it's confusing. Auto hotkeys is a program that I use to store text that I type over and over again, so I don't actually have to type it over and over again. And so we'll want to cache references to the child components of this game object, and we just want to get our scripts. So we want to set our transform component to be equal to this get component transform, and then we want to do the same thing with our player character and our player camera, so that way we have our references. Now for the animator and the controller, it's going to be a little bit different. Again, this is just a little bit more of an exercise. It's really not any kind of an efficiency boost, but for our animator and our controller, we want to get those from our player character, because remember, we're funneling all of our components in through our player character script. Okay, and so that does it for our start method, and we'll want to go into our update method. And the first thing that we want to do is we want to get our camera state from our player camera script. So we'll set the camera state to be equal to whatever the camera, so our camera script, we've set to be this .get component player camera, and we're getting the accessor camera state, so camera.camera state, and that'll give us a local reference to that camera state. Okay, and we also want to set up a finite state machine for that as well. So we'll use another switch statement, and we'll give it cases. So case camera state dot normal, and one for our target as well. So camera state dot target, just in case we want the movement to behave in different ways depending on the state. And this is an example. Like I said, we're not really going to be working on the targeting state, but in mecanim you can have multiple different layers, so really you could construct a layer for the normal state and one for the target state. So that way the target state, if you're holding a rifle or something, then you could set up the mecanim blend tree to behave in a different way depending on the state. Okay, and so that's just really the reason that we want to use an FSM for that, and that gives us a little bit more expandability and whatnot. And we're going to want to calculate our move speed in a state machine as well. We'll do that in a different method, and I'll just call this one calculate speed. And so our switch statement is just going to set our move speed to be whatever the state is. So in case the speed state is equal to walk, then move speed equals walk. Same way with run speed and sprint speed. Okay, and so we want to go ahead and we want to call that method in our update function outside of our current state machine, because we don't want to nest those and we don't want any kind of inefficiency off of that, so we'll just put that outside of the switch statement. Okay, and so we want right now our system only allows us to look up and down, so we want to be able to rotate as well, and without using a bunch of complex referential shift math, we're going to be able to rotate the player, and it's not going to be that intuitive in the sense that your camera can face any direction of the player, but rather the movement of your right X input is going to determine the rotation of the player. Okay, so we'll just go ahead and add that in, and we actually should be able to go ahead and test that out. Well, no, we actually need to go ahead, and I'm gonna do this in the start method. This is only temporary. I want to set that. I'm gonna say animator not set set bool, and we'll say animator conditions not grounded, and we want to say that's false. Okay, actually, I'm sorry, I want to say that's true because it's false by default, and that's going to make our player play the fall animation. Okay, so we'll let this compile. Go ahead and play the game. And so here we are idling. We can look up and down, and when we turn left and right, it turns the entire player. So that's the behavior that we're going for. Okay, and it's really nice for third-person shooters like this, especially for the targeting state. Like I said, we don't want to do anything too complex to be too confusing at this point in time. But we'll go ahead and go in and finish this off. So now we want to do a check. Go ahead and remove this. Actually, no, we can leave that in there, and it's perfectly fine. So after we allow the player to move, we're going to do a quick check and see if the character controller is grounded. And then if it's not, we want to do some other stuff. But if it is grounded, then we want to initialize our move direction vector to be equal to 0 again, and you'll see why we want to do this here in just a moment. Then we want to set our air velocity to be equal to 0. Again, these are corresponding to each other, so you'll see why that we do that in just a moment. And we always want to set our animator references. So we want to set our air velocity and our grounded variable. So we're going to say that our animator conditions air velocity is equal to air velocity, and our animator conditions grounded is equal to true if it's grounded. Okay, and as a matter of fact, we could actually move this and put that outside of our state machine, so that way we'll just cut down on the amount of code we have to write. Okay, and now we want to go ahead and cache our input value, so I'm going to put in a comment here, and we'll set our horizontal and vertical variables to be equal to the axis that it corresponds to. Player input horizontal, player input vertical. Okay, and now we actually want to set those values in our animator conditions. So we'll say, get where I'm supposed to be, and we'll say set the direction to horizontal. So if we hold left or right on the stick, then it sets that input value to the horizontal condition in our animator state. And the same way with up and down, just vertical, or for the speed, we set our vertical axis. Okay, now we also want to check if the player presses the jump button while it's grounded, because we don't want to actually execute this code if they're in the air. And if they jump, then we want to do some stuff. So in order to separate this out and make this look a little bit, I guess, a little bit more user-friendly, we're going to put this in another method, and we're going to call this private void jump. Okay, it doesn't accept any parameters. But then we want to set the move direction value for y to be equal to that jump height variable that we set up here. So the y parameter in the vector 3 of move direction, we want that to equal jump height. Then we want to take our air velocity and subtract from that time.time. So the amount of time that they've been in the air is the amount that air velocity will equal. Then we want to set the float. Again, well, I don't think that we really need to do that. Set the animator conditions velocity. We'll try it out. We'll try it out this way without adding this in. I was going to do something like this, but since we're calling that outside of the state machine, I don't think we really need to do that. Okay, and so if the player presses the jump key, then we want to call the jump function. Okay, and if they're jumping, then they're going to be obviously in the air, so we want to do some things for this. And we want to set the x and z values in our move direction vector to be equal to the input axis. And the reason that we do this is because we want to give the player a precise jump. So without this in here, then if you jump, all that will happen is you will jump, and then any calculations that are being made prior to that will be fed into the move direction variable. Instead, we want to actually give the player control over that so they can move left and move right and move forward and backwards while they're in the air just slightly. And we're going to multiply that by the move speed. Okay? So now we can take this by itself will not be enough for that to work. We also need to use the transform direction method on our transform, and we want to pass in the move direction vector that we've created up here. Okay, and the last thing that we want to do, we just want to go ahead and set the grounded parameter in our animator to be equal to false, and that should be enough to get us moving around. So let's go back into Unity and go ahead and hit play, and let's start looking around. So if we hold forward, okay, I've got some weirdness going on with it. Looks like the left strafe. Oh, looks like Michael Jackson a little bit. Okay, I'll go ahead and look into that in just a moment, but if we go in any other direction, it looks like we can move appropriately. Kind of. Doesn't look like our jump button is working either. So I'm going to pause the video and troubleshoot this, and I'll get right back. Okay, I'm not really sure what happened. However, when I did restart Unity, it seemed that the bug went away. I assume that from that it probably has to do with the transitions. I may have set up the logic in an incorrect way. I don't really want to go through and find the bug, so sorry about that. But what I will go ahead and say is that this can be a problem. I did forget to mention this. The atomic variable, or the atomic selection, you actually want to turn that off on all of your transitions, because that will require that the entire animation that is playing finish before the transition can happen. So we don't actually want that. It can really slow down gameplay. There are certain instances when it can be useful. However, I don't really see any purpose in having that, having this functionality in this tutorial. So we'll go ahead and change these all to off, and yeah, we'll go ahead and play this and see what happens. Okay. Okay, so yeah, I definitely have a value incorrect in the state machine. Looks like more so with the right than the left. Alright, so yeah, I'm going to go ahead and I'm going to troubleshoot that, and I'm going to figure out which ones I have incorrect. And again, I'm going to pause the video and I'll be right back and we'll finish this up. Okay, this is a silly mistake. These transitions, I never set parameters for them. So going from locomotion to strafe left, you want to set that direction to be less than -3, and you want to set the speed to be less than 3. Going to locomotion, you just want to check if the speed is greater than 3. And then the same way vice versa over here. I forgot to set those parameters. After correcting the parameters though, it does look like it's functioning appropriately. So we can run left, and if we just barely hold on the stick, then we can kind of trot. So we got a nice little locomotion going on here, and we can face any angle. Again, this is something else that I didn't explain. I do apologize for all the things that I skipped. The reason that this works the way that it does, and we're not actually calculating any movement, any kind of movement values with that move direction vector in our script, is because if you go to the animator component, this is checked on by default, but this apply root motion. This will actually make the movement be driven off of the animations rather than by script. So you can just check this on and your animations will actually move your character for you. So since our blend tree is telling if I'm holding just slightly up and right on the stick, then he's moving diagonally. And so that's why we're able to do this. We're driving the character controller off of the animations themselves. Okay, so we'll go ahead and finish this up and implement jumping. And so all that we need to do for that, and we'll go back into our script, get rid of this debug statement in here. If the player presses the jump button, then we call the jump method. And okay, so outside of our state machine, we actually just need to do our physics calculations, or our fake physics calculations. So the first thing that we need to do is obviously apply gravity to the character, and so we do that by taking that move direction vector dot y and then subtracting from it the gravity times time dot delta time. Then we also want to allow the character controller to be moved by that vector. So we take the character controller, the controller component of our instance, use the move method on that, and then supply it with the move direction vector and multiply that by time dot delta time. And if we save this off, we should be able to jump in our game now. Okay. So we hit the jump button and there we go, we're jumping. And because we are actually calculating movement based on the axis, when we are in the air, then it makes jumping onto objects a lot easier too, so it's a lot more precise. We can just simply jump on this cube. And there's still a lot more that we can do to smooth this out, such as if you get into situations where you're right on the edge of an object, then you get stuck in this kind of fall slash jump state. But other than that, this is a pretty serious little character controller here that you can take anywhere with you in any of your projects. So yeah, just to show you the power of this, I'm going to go ahead and delete this. I never prefabbed it. And I'll go into our controller assets, bring in a fresh new beta model, just drag her into the hierarchy there, position her somewhere over here, and if we select her, we see there's no components added to her whatsoever. So we just go to add component, add our player character in, and play. And now we can move around just as before. And that's it for our third-person controller tutorial, and hope to see you again, and tell us what you think. Take care.